Hello everyone, I'm Yang from the College of William Mary. In this video, I will demonstrate B, a tool for structuring and analyzing bug reports. Bug reports are essential in helping developers triage, replicate, locate, and fix the bugs in the software. A good bug report can decrease the time required in fixing a bug. However, sometimes the bug reports are not complete and clear. The consequence of this is that developers often spend too much effort triaging and fixing the problems. One of the main reasons for having low-quality bug reports is a lack of the feedback and quality verification of issue trackers, such as GitHub Issue Tracker. So we want to improve GitHub Issue Tracker to help the reporters provide necessary elements and help developers get higher quality bug reports. To solve this problem, we developed B, a tool that can analyze and structure incoming issues. One feature is that B can detect the type of the issue. That is, an issue can be classified as a bug, a question, or enhancement. This can help developers prioritize and manage the issues. So if the issue is a bug, B can alert reporters about the missing elements. The first element is the observed behavior. We refer to it as OB. The second one is the expected behavior. We refer to as EB. The second one is a step to reproduce the bug. We refer to it as S2R. So B can help reporters provide the missing information when they are submitting issues. Another feature is that B can structure bug descriptions by identifying and labeling sentences. It's intended to help developers understand the bug reports better. B also offers a public web API for automated sentence identification. Users can send any piece of text to this API. B parses the text into sentences and returns the sentences with labels to the user. This API can be useful in bug reproduction, bug localization, and bug report quality assessment. Researchers can also use it to create new tools. This is architecture B. B implements two classifiers. One classifier is to classify issues. This classifier uses fast text to implement the model. Another one is to classify sentences. It uses support vector machine implemented by SVMLite. B is able to detect missing elements in a bug report. B also implements a controller that is able to communicate with GitHub to create new comments and annotate the text. And also B provides a web API that developers can use to automate the sentence identification. B is a GitHub app built by Node.js, which uses GitHub webhooks that allows integration with GitHub Issue Tracker. Now I'm going to show you some examples. This is an example of a bug report. This bug report is from the Eclipse software system. In this case, you can see because this issue is a bug report, B added the bug label to this issue. If the bug report doesn't provide observed behavior, expected behavior, or step to reproduce, B makes a comment about it and prompting the user to provide information in the bug report. If any of the elements are missing, this issue is assigned to the reporter and B adds an info needed label to the issue, which indicates the information is needed. Finally, B structured bug description by identifying which sentence describes observed behavior, expected behavior, or step to reproduce, and B assigns a label and applies a label to each one of the sentences according to what they describe. This helps developers easily identify these elements in the bug reports. Let's look at another example. This issue is taken from this project. Now I'm gonna submit this issue. As you can see, in this case, B identifies the issue as a question. Indeed, the reporter was asking some question. Because the issue is not a bug report, B will not further analyze this issue. Now let's look at the next example. This issue is from the Docker software system. As you can see, the big difference of this bug report from the previous ones is that this issue contains a code block. So in the second comment, B labels the code block with one of the types of elements like OB, EB, and S2R. In this case, it's OB. This is because B treats each code block as a single piece of text. Let's look at the last example. B can analyze any bug report in any format for any software system. In this case, this issue contains all the three elements: observed behavior, expect behavior, and step to reproduce, and the format is using GitHub Markdown. After we submit the issue, you can see B assigns a bug label and indicates the bug report appears to be complete. And also structure the bug description. As you can see, the format of this bug report is preserved. As I mentioned before, B provides a public API that researchers can use for automated bug management. They can send API requests containing any piece of text. Now let me show you how to use this API. We set post as a request method, and this is the API URL, and we input our bug report as a request body, and then we send the API request to B. As you can see, B returns a list of sentences. Each one is tagged as the OB, EB, or S2R. We conduct the evaluation of B. Our goal is to measure the performance of B's models in detecting OB, EB, and S2R sentences and missing elements. As data, we use more than 5K bug reports from 35 systems. For the model selection, we use 3 binary SVMs for classifying the sentences. The features we use are n-grams and part of speech tags. This representation can capture sentence vocabulary, word types, relations between consecutive words, and the syntactic patterns that can help with the classification. We perform 10-fold cross-validation to measure the accuracy of 3 SVM models. The result of sentence classification shows that B's model achieves more than 87% recall and more than 70% precision, which indicates their ability in detecting OB, EB, and S2R sentences correctly. The results also shows that how the overall performance of B at detecting missing OB, EB, or S2R in an entire bug report. When detecting missing EB and S2R, B achieves substantially more than 93% precision and more than 70% recall. As you can see, the result shows low performance when detecting missing OB. However, only 2% of the bug reports lack this information, so we expect that there's a minimal effect in practice. Based on the results, we can conclude that B can have a positive effect in collecting higher quality bug reports and automating tasks like bug report management. In summary, as the problem is the low-quality bug reports, we propose to improve GitHub Issue Tracker by developing B, a GitHub app that can detect missing elements in bug reports and can also detect type of the sentences, so it can help reporters and developers collect better bug reports. B implements a set of machine learning models for classifying issues and sentences. We evaluated the models and the result shows that B is accurate, so we expect that it can have a positive effect on reporters and developers on GitHub projects. We invite you to go to this website to know more about this tool and to install it to your GitHub projects. Thanks for watching.